Okay, AP Environmental Science. We are moving through Unit 4, and today we're going to discuss topic 4.4, which is on the Earth's atmosphere. This topic, I think, is kind of easy, kind of cut and dry, kind of black and white. I think kind of easy to understand. There's not a gray area with this stuff, so should be pretty quick to get through this particular lesson today. So let's go ahead and start off with just some of the essential knowledge that you're going to be expected to know um, for this particular topic. Two major things. The atmosphere is made up of major gases. All right, so we're going to go through some of those gases today and kind of discuss, what the atmosphere is made of, what gases are more abundant than others. We'll also talk about different layers of the atmosphere, and there are kind of five distinct ones that we'll talk about. A few of these are a little bit more important than the other ones are. So again, I'll get through that as I go through the lecture today. All right, so let's kind of start today with what's in our atmosphere. Find the best place to put myself. Let's put myself over here for right now. All right, so this is a list of pretty much everything that's in our air, our atmosphere. Um, and they list each component here. They even give you the symbols of each one, and they give you sort of the, I guess, relative abundance of each one as well. Now, a couple of things that I think are sort of important from this list. The first is that these top two things here, nitrogen gas, N2, which we should be familiar with, and oxygen gas, O2, those two gases alone, if you added them up, that would basically be 99% of the atmosphere. Okay. So, I mean, 99% of our air is nitrogen and oxygen. Now, if you just kind of drew a line underneath oxygen, and kind of looked at all of these other things, that's basically the other 1%. Okay, now some things are a little bit more abundant than others are, argon and carbon dioxide, a little bit higher than some of these other ones, but everything underneath oxygen is pretty much, very, very minimal. Now, that doesn't mean that those components of our atmosphere are not important, because they have some interesting things about them I think that we should know. I'm going to go through some of them for you. I'm not going to go over all of them because they're not that important, at least for this class. But one of them, for example, I'm going to move myself back over here. One of them is carbon dioxide, which we've talked about before. Now, the thing about carbon dioxide, even though there's not a lot of it in the atmosphere, it is a greenhouse gas. All right, so G gas, greenhouse gas. We should know kind of what that means, right? It contributes to global warming. So that particular gas has increased by 25% in the last 200 years. So we've talked about this before. There's some major anthropogenic causes of this, burning fossil fuels, deforestation. We should know that. Okay, that's important. These two I kind of like to talk about together. SO2, which is called sulfur dioxide, and again, you all took chemistry class, so yeah, I expect you, when you see a formula like this, I expect you to know the name of it. All right, and if you see the name, I expect you to write the formula. Sulfur dioxide is SO2. Nitrogen dioxide is NO2. Now, what's interesting about both of these is they are both components of acid rain, and we'll talk more about acid rain, down the road a little bit. But I mean, I think you probably all have an idea that if there's acid in rain, that's probably not a good thing for the environment. Okay, SO2, for example, is put up into the atmosphere by burning fossil fuels. So again, every time we burn a fossil fuel, coal or oil, natural gas, basically, we put this stuff up into the air. So, I mean, even though there's not a lot of SO2 in the air, it is on the rise. Okay. The thing about SO2 is when it gets into the atmosphere, it turns into an acid. This is sulfuric acid. You might remember that from chemistry class, H2SO4. I do want you to recognize this formula. Again, it is an acid. Acids are basically hydrogen and some negative ion. In this case, it's sulfate. But that acid, if it gets into the air, it's not really a good thing. All right, down here is kind of the same thing, NO2, which also is put into the atmosphere through burning fossil fuels. When that stuff gets into the air, it turns into this acid, which is nitric acid, HNO3. So the big thing I want you to know about SO2 and NO2 is that when they get into the air, all right, they have the potential to turn into acids and can come back down to the earth in the form of acid rain. So make sure we know that about those two particular um, atmospheric components. CH4, this is another greenhouse gas. This is called methane. All right, methane has increased by 150% in the last 200 years. Now, again, there's some anthropogenic reasons for this. One of them is natural gas leaks. When we drill, for example, into the earth, some of that natural gas leaks out and it goes up into the atmosphere. Another one is raising livestock. Believe it or not, every time a cow or a pig farts, animal farts, they release methane. So you might think, well, big deal. I mean, cows and pigs have been around for a long time, and that's true. They've been around for a long time. But we are raising more of these animals to feed, 7.8 billion people. So the more of these animals that we're raising, the more methane gas they're going to release, and it's going to go up into the air. So this is becoming an issue because, again, it's a greenhouse gas. Here's another one is N2O. Don't confuse it with NO2. This is called nitrous oxide. It's another greenhouse gas. Again, some anthropogenic causes, burning fossil fuels, that one's becoming redundant. And also excess fertilizer production. When we produce excess fertilizer, that can release N2O, which is a greenhouse gas. And finally, ozone. Ozone, the formula is O3. Um, ozone, we sometimes tend to think of ozone as being a good thing, and it is. It can be. It blocks ultraviolet radiation from reaching the Earth, which we'll talk a little bit more about today. But it can also be a major component of air pollution or smog. So that kind of is a bad thing. All right, so this list here, one, two, three, there's 6 things that I think are pretty important that we know. So most of these we will continue to talk about throughout the year, but I think it's a good idea initially today to try to get a grasp of why each one of these things, as they build up in our atmosphere, are kind of considered to be kind of bad things. So make sure we know that. All right, now layers of the atmosphere. Let's kind of continue with this and kind of finish off with this today. Before we get into the individual layers, and there are 5 distinct atmospheric layers. One thing I think is important to understand is what happens to air as we elevate or as we get closer to the Earth. And if you look at this picture here, it's very simple. It's basically just a column of air. So imagine there was like this tube, like going up, like miles up into the air, and it's just filled with air. Okay. One thing you'll notice about is all these little particles, right? The closer you get to the Earth, the more densely packed those particles are. So, like air, is more densely packed as we get closer to the Earth. And as we elevate or go higher up in altitude, those molecules tend to spread out a little bit more. Now, that has an impact on temperature. right? I mean, you might remember this from chemistry class last year. You guys did a unit on gases and properties of gases, and air is a gas, right? Or it's a mixture of gases. But when we get closer to the Earth, when those molecules get closer together, they're colliding a lot more. And when they collide with each other, they generate heat, right? Those collisions. So you would imagine that the more densely packed the air is, the more potential there is for heat to be generated, and that's the truth. So as we get higher, we would think that the temperature would decrease. All right, so kind of remember that. All right, so here are our um, different layers of the atmosphere. And just kind of starting, we'll kind of start down here. This represents the surface of the Earth. We have our troposphere, and then the stratosphere, the mesosphere, the thermosphere. There's actually one more layer called the exosphere. It's above the thermosphere. That's basically just outer space, the exosphere. So I didn't list it on this picture, but that's okay. All right, so what we're going to talk about today is these major layers and what happens to temperature as we go up in altitude. And you see this red line here, it kind of represents temperature. And over here on these y-axes, these represent altitudes. This one here is in miles. This one here is in kilometers. Don't worry so much about that. But so let's start off with the first layer. The first layer is the troposphere, and it is the layer that is closest to the Earth. All right, we all live in the troposphere. That's where we live. We're going to spend our entire life in the troposphere for the most part. Okay, unless you're in an airplane, you might fly a little bit above it, but for the most part, you're going to be on the Earth. This is the layer of our atmosphere where all of our weather occurs. All the weather occurs in this particular region or this particular layer. So, you know, all living things live in this layer. So, for the most part, all the weather, can have an impact on living things. So we'll spend a lot of time talking about troposphere. It goes up about 8 miles above the Earth's surface. So, for what it's worth, about 8 miles. Now, one thing I think is important is that we understand what happens with temperature as we elevate through the troposphere. So again, you'll notice the red line here. Okay, so if we're starting at the surface and we're going up, that's what this is kind of showing us. We're going up and up and up and up. Air temperature is going to decrease, and we would expect it to, right? We talked about that column of air, right? So as the molecules get further apart, it's going to get a little bit colder. Imagine if you're climbing a mountain, right? The top of Mount Everest, for example, which reaches all the way up to, sort of the upper regions of the troposphere, it's going to be a heck of a lot colder up there than it's going to be at the base of the mountain. Okay, so that's why mountain climbers, they dress pretty warmly because once they get a little bit higher up, it's going to get freezing cold up there. All right, now the top part of the troposphere is called the tropopause. It's basically kind of an imaginary line where the troposphere ends and the next layer begins. Okay, so you see that term, is what it means. All right, now the stratosphere. The stratosphere goes up about 30 miles above the Earth. All right, so it goes up a little bit higher. Now, one thing that you'll notice about the stratosphere is that the temperature goes up. I mean, you would think that, as you're elevating, the temperature would continue to drop, but that's not really what's happening here. So we need to kind of understand, why is it that temperature decreases through the troposphere with elevation, then all of a sudden it increases in the stratosphere with elevation? It doesn't seem to make any sense. Now, the reason why that happens is because of something that's right through the middle of the stratosphere, and that's called the ozone layer. You're probably familiar with that term. The ozone layer is literally a layer of ozone, And ozone is a molecule that has the formula O3, so I want you to know that. But ozone is really important, that ozone layer, because again, it blocks ultraviolet radiation from the sun, and it blocks it from reaching the earth. So, here's the sun, it produces ultraviolet radiation. Now, some of that radiation does leak through. That's why you have to wear sunscreen when you go outside, because you don't want to get a sunburn and you don't want to get skin cancer, right? So, but the ozone layer does a pretty good job of blocking most of that ultraviolet radiation. If there was no ozone layer, there would be no life on Earth. That's how important it is, because it blocks so much of that radiation. And if all that radiation were allowed to come through, then nothing living could survive. It's that important. So, that radiation that gets blocked, what happens is it tends to accumulate in the upper regions of the stratosphere. All right, and that ultraviolet radiation is associated with heat. So, as you elevate through the stratosphere, the temperature actually rises because of all of that radiation that's being built up, in this upper region up here. All right, so I want you to understand why that occurs. Again, we would expect the temperature to drop as you go up, but it continues to rise, all because of that ultraviolet radiation that is found above that ozone layer. All right. So again, the stratosphere, extends from the tropopause all the way up to the upper level of the stratosphere called the stratopause. All right. Now, really, there's three other layers, but I'll be honest with you guys, there really isn't much you have to know about these. Okay. The one thing I want you to know about them is the order. Okay, so again, troposphere is at the bottom, stratosphere, and then the next three layers in order are the mesosphere, thermosphere, and exosphere. All right, you don't have to know really much about these other than maybe a couple little details here. The mesosphere is kind of that middle layer that's right above the stratosphere. This is a layer where most, like, meteors, when they're coming through the Earth, they get burned up before they reach the surface. So that's kind of a good thing. It's really, really hot in there. The thermosphere, this blocks X-rays. X-rays are another type of radiation that are produced from the sun. It also forms the northern and southern lights called the aurora borealis, which is what this picture is showing you here. Maybe you've seen them before if you've ever, like, gone up to Canada, like in the upper regions of Canada or Alaska. You have a good chance of seeing these things. But anyway, it's all because of the X-rays that are accumulating in the upper regions of the atmosphere. Then we have our exosphere, which again is the outer layer closest to space. All right, so just kind of know the order, maybe know these things here, and that's about it. But the troposphere and the stratosphere, those two are big ones. Okay, so again, let's revisit our essential knowledge. Again, the atmosphere is made up of major gases, each with its own abundance. You don't have to know every gas, just those ones that I talked about today, I think, are ones that we should focus on. Then, of course, we talked about the layers of the atmosphere. Again, troposphere, stratosphere, those are the big ones. All right, mesosphere, thermosphere, and exosphere, kind of the minor ones. All right, guys, have a good day. I will talk to you soon.